the last lesson or last part of the lesson for this week. Turns out we have a double, and the guys work really, really fast here, so I have to just do that as well. So I will ask you to first of all draw a tan graph for 0. So put in your tan 0, 45, 90, 135, go up in 45 all the way to 360. Draw a graph. So draw a table and then use a graph for that. Tan theta. Okay? And then please watch this video. What you'll find, you'll see a graph that looks something like that. Start from 0, it goes up. Okay? If you put tan 90, you'll get an error. It'll say error. I'll explain what that means. Okay? And then it crosses again at 180, cross the 0. Again, you get an error at 270. Okay? And then at 360 is go back to 0. Okay? Now, I haven't done the best job in drawing this tan graph. It's a little bit awkward. So please have a look at page 92. Okay, we're in page 92. Okay, we'll get a nice better version there. But we need to understand what's happening first of all at these 90s. Okay, 90 and 270. Okay, so I'm going back to it. To understand everything is that circle. That is so important. I know it's a bit difficult, but it really is worthwhile understanding it because it will help you trig for next year as well. So you know we've got that triangle. Okay, yeah, this is, let's say, theta. And if this is a certain point with a coordinate x and y, the hypotenuse is a certain distance, which is all the time the same. It's a radius. We'll give it an r. This distance is your y. That's your y coordinate, meaning this is the x coordinate. Okay? Now, tan theta is your y, it's the opposite divided by adjacent. Okay? Opposite divided by adjacent. In other words, it's y over x. Okay? Now, what happens? Why is it going so wrong? Why do I get that error message when tan 90? What's happening in 90? Well, at 90, our point is over here, right? Theta is 90, is here. This is theta equal 90. Okay? Write that down. Theta equal 90. Now, what is the y coordinate here? I'm asking you. What is the y coordinate here? It's the radius. I don't know if that's what you said. It's r. Okay? Y is equal, the full r is here. Okay, last week when you guys were here, I said, okay, let's choose r being 1. I used 2, but let's use it 1. So in this case, y is equal 1, right? So y over x is going to be equal to 1 divided by x. What is the x value here? 0. Right? Because here, you see here on the y-axis, the x is actually 0. So what is 1 divided by 0? Undivided. Error. You get a message error. If you put 1 divided by 0, so I'll be talking to you as well. 1 divided by 0 is infinity. It's error. Okay? Why is it error? Because actually it's infinity. Think about it. You do divide, say 1 divided by 2. Okay, that's a half. Let's make 2 smaller. 1 divided by 1 is equal to 1. Move on to 1 divided by 0.5, it is 2, getting bigger. 1 divided by 0.1, 10. 1 divided by 0.01, 100. As you make the denominator smaller and smaller and smaller, your number becomes bigger and bigger and bigger and bigger. So that means if you divide 1 by 0, you get a number which is bigger than any number there is. That's infinity. So, what happens as I'm getting closer and closer to 90? Okay? My y becomes bigger, get closer and closer to 1. The x becomes smaller and smaller and smaller. So, tan theta becomes bigger and bigger and bigger. And actually at 90, there is no number that I can give it because it's bigger than any number. Okay? So, what we say, or I say, is that graph blows up to infinity. Blows up. Okay? And the more mathematically way of saying it is that there is a vertical asymptote. Okay, a vertical asymptote. We will come across these asymptotes in other functions. Our next topic is function. Okay, so we have to understand this vertical asymptote here. Vertical asymptote means that the graph will get closer and closer to this vertical line, but it will never really touch it. We only touch it in infinity, but we can never get to infinity, isn't it? Does that make sense? Okay, now, what's happening at 270? 270, we're over here. Okay, this is 270. In this case, the y is going to, I'm just going to make it a little bit quicker. Y is going to be equal to minus 1, and the x will be equal to, what is the x at this point? It's 0, isn't it? It's 0, okay? So again, the tan is going to be minus 1 divided by 0, which is minus infinity, okay? So again, we've got another vertical asymptote at 270. Now, there's a little bit of a subtle point here, because if I'm going beyond 90, let's say I'm going to 91, okay, 91. Now, the y now is almost 1, okay? The x is very small, so I'm going to have almost minus 1, minus like 0.999, divided by a certain small number. So it's going to be a very large number, but negative, right? So as I move just across from 90, this is the 90, then I'm going to get another, it's the same vertical asymptote, I'm going to get minus infinity, basically. Okay? So if I move it just below 90, I get a very large, theta will be very large, positive. If I just go over 90, theta will be very large, but negative large. The same thing in the 270. If I just go before 270, okay, y is negative, is negative 1, but also the x is negative 1. If I'm here, x is also negative. So negative divided by negative is positive. Okay, so just before 270, okay, it blows up to infinity. Just after 270, as I move on to here, the y is still negative, but the x now is positive. So we're going to get negative divided by positive will be negative. I know it's a little bit, quite a lot to take in, and if you don't get all of it, it's not a big disaster. What you really need to know is how to draw this graph. That's what really matters. Okay? Now, I've asked you to go from 0 to 360. Okay? How are we on time? Yes, I've got a couple minutes. So, really, the graph from 0 to 360 looks like this. It goes up to infinity, 90, and it goes from 90 to 180, then goes up, and then again up to 360. There are some points that the textbook called the critical points. And the critical points are where theta is equal to 45, 135, and then another 45, 25, these points. Okay, I'll explain them now. 315, and that's it. What's happening there? Let's look at 45. When this is 45 degrees, what will that angle be? This is 45 and this is 90. What angle will that be? 45 as well. So what can you tell me about x and y? If this is 45 and this is 45, they're the same. X and y is x equal to 1. Okay? So tan 45, which is equal to y over x, is going to be equal to what? 1. So at the critical, just stay with me guys, the critical points, which happens here, 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 and here, okay, the x and the y's are the same. So we're going to get 1. 1 or minus 1. Over here, we're going to get minus 1. This is 135. Why minus 1? Because the y is positive, but the x is negative. So it's minus 1. They're equal to each other, but one is positive, the other one is negative. Here, both of them are negative, so it's going to be negative divided by negative, it's positive. That happened in 225. 315, okay, is going to be y is negative, x is positive, so it will be negative 1. Just keep you for 1 minute, because I wrote it down, and otherwise I forget to do it. Okay, we can obviously extend the angles beyond 360, okay, and you'll find the same thing, that the graph will repeat itself. The graph will repeat itself. So from 360, it's as if I was at 0. Okay? It goes up again. It's the same. Okay, I didn't draw it here, but we're also going to have something like this, like that. But for the first time now I'm telling you, and Ollie noticed it, that we can actually have negative angles. So if I wanted to extend it to the negative domain, I can do it. And it's going to go like this. So I'm just copying it. Okay? Alright? What is a negative angle? We will talk a lot about next year, but just since we've seen it, I don't want to put it there without telling you what is a negative angle. If 45 degrees, positive 45 degrees means that I moved it to this side, minus 45 degrees will mean that I move the radius in which direction? Downward. So minus 45 is just moving downward. Okay? I've pushed a lot of stuff on you now. I think that will be enough for it, guys. Have a lovely week.